You're swimming in the ocean. The water is clear, the surface is calm, and nothing visible suggests any danger. But somewhere out there, up to 5 miles away, something already knows you're there. Not because it saw you, not because it heard you, because a single drop of blood entered the water, diluted to 1 part per million across an Olympic swimming pool's worth of ocean. And it was enough. The great white shark was already moving before you knew you were bleeding. Most people think of the great white shark as a visual predator. The iconic dorsal fin cutting the surface, the predator scanning for prey with its dark eyes. That image is accurate, but it tells almost none of the story of how a great white shark actually locates, tracks, and closes in on prey. Vision is actually one of the last senses a great white uses in a hunt, not the first. By the time a great white shark sees its target, it has already been tracking it across miles of open ocean, using a sensory system so sophisticated that researchers are still mapping its full capabilities. It starts with smell. A great white shark's nostrils, called nares, are not used for breathing, only for detecting chemical signals in the water. Roughly 2/3 of the great white's brain is dedicated to processing olfactory information, and its sensitivity is extraordinary. 1 part per million, meaning 1 drop of blood diluted across roughly 25 gallons of water is detectable. In optimal conditions, with ocean currents carrying the scent trail directly toward the shark, detection distances of up to 5 miles have been documented. The shark doesn't swim randomly toward the smell. It tracks the scent gradient, moving toward increasing concentration the way a tracking dog follows a trail, adjusting course constantly as the chemical signal strengthens. But smell is only the beginning. As the shark closes to within roughly 800 feet of its target, a second sense activates, the lateral line, a system of fluid-filled canals running along both sides of the shark's body that detects pressure changes and vibrations in the water. A struggling fish, a swimming human, a heartbeat, all create pressure waves that the lateral line reads like a map of movement, allowing the shark to track prey in total darkness or complete murk where vision is useless. The lateral line is sensitive enough to detect the movement of a small fish from 800 feet away through open water. Closer still, within roughly 300 feet, the shark's hearing engages. Not through ears in the traditional sense, but through an inner ear structure that detects low-frequency sounds, the kind produced by struggling or injured prey. Frequencies between 25 and 50 hertz are particularly attractive, which is almost exactly the frequency of an irregular, struggling swimming pattern, rather than smooth, regular movement. The ocean is full of sound, and the great white's auditory system filters for the specific acoustic signature of vulnerability. And then there is the Ampullae of Lorenzini, arguably the most extraordinary sensory system of any predator on Earth. These are hundreds of small pores concentrated around the shark's snout, each connected to a jelly-filled canal that leads to sensory cells capable of detecting electrical fields. Every living creature produces a bioelectric field, the electrical impulses of muscle movement, heartbeat, nerve function. The Ampullae of Lorenzini can detect electrical fields as weak as 5 billionths of a volt per centimeter. To put that in context, a great white shark can detect the bioelectric field of a fish buried completely under sand on the ocean floor with no visual, olfactory, or acoustic signal available whatsoever. In the final moments of an attack, when the shark closes its protective nictitating membrane over its eyes, which it does to protect them from prey, it switches entirely to electroreception to guide the final strike. It attacks blind, guided by electricity alone. Layer all 5 of these senses together: smell from 5 miles, pressure detection from 800 feet, low-frequency hearing from 300 feet, electroreception from inches, and you have a predator that builds a complete, continuously updated picture of its target across miles of open ocean, using a different sense at each stage of the hunt, with each sense taking over precisely where the previous one reaches its limit. No single sense dominates. They cascade, each one handing the targeting solution to the next as the shark closes in. The great white shark has existed for around 11 million years in its current form. It has outlasted ice ages, mass extinction events, and the rise of every other apex predator on this planet. And the reason isn't its teeth, or its size, or its speed. It's this: a sensory system so precisely layered that almost nothing in the ocean can hide from it, bleed near it, or move within its range without being detected, identified, and tracked. The ocean isn't the shark's hunting ground, it's the shark's laboratory, and every living thing in it is constantly broadcasting its location. Which of the 5 senses surprised you most? Drop it in the comments, and subscribe to NatureCrest for more deep dives into the animal kingdom's most extraordinary and most dangerous hunters.